This is basically the recipe for the cold fusion. Okay, diamagnetic. Alright, hydrogen is basically diamagnetic, so you need your diamagnetism. That is the gravity. You get your four fundamental forces here to emulate a star. Alright, you have to have your alpha particles for your weak interaction. You have to have the thermoelectric energy, or the radio new isotope thermoelectric generator, basically, for the plasma arc, which is the strong interaction. Okay, your helium-4 nuclei for your nuclear energy, and your ionized hydrogen to fuse with it. Okay, pretty much what you're going to do is you're going to use this radioelectric or radionuclear arc to fuse the ionized hydrogen and the helium-4 nuclei, and this will basically form lithium. Like, here's your hydrogen. You have a cathode or anode, your electrode basically, or anode right here, that ionizes the hydrogen. It's all put in here at a focal point basically, and arc is basically generated. You have your electrodes here, you have your anode and your cathode. Your electrons are coming from here. Your alpha particles, since they have such a positive charge, they come out with protons, and these two together are obviously going to have immense heat. Like, we use MIG welders and plasma torches and stuff like that. I mean, you got your plasma right here with your thermoelectric energy. You're basically a thermonuclear energy, thermonuclear arc. Plasma is being formed right here, and lithium is going to be the byproduct. And most likely it'll be red, because a type T brown dwarf puts off a lot of lithium, and then when it fuses and it's a very reddish color. I believe this would be like a crimson colored star. You know, you got your fourth state of matter, or your fifth element basically is plasma. So you're basically fusing compressed ionized hydrogen with helium-4 nuclei, just like the sun does, through an immense heat, just like the sun does, with thermoelectric or thermonuclear energy, because you need the energy. Now, scientists, what they do is they compress the hydrogen in a magnetic field, and they try to light it, basically. They try to get it to ignite, but what they're doing is just compressing hydrogen. They got plenty of fuel, but there's not enough energy. There's no energy. In space, you have gravity, which acts as a lot of energy, and we only have 1 G on this planet, you know, so they can't emulate the gravity enough by compressing this. But if you add the energy here and the gravity, then you can compress this ionized hydrogen in a field and actually burn it through a nuclear arc. Okay, and radioisotope thermoelectric generators, or thermoelectric generator, nuclear generator, atomic batteries with the cathode and anode, open arc is an arc light basically, or have an arc light basically with the 369. Now Tesla talks about 369. Now obviously Tesla, he's going to look up the elements, okay, and the elements electronegativity, and it would incorporate the p-type and n-type material. Now you do need these materials to make it work, because you need your positive and your negative, and these are the most 3, 6, and 9. Lithium is a very low electronegativity, while fluorine or fluorite, number 9, is the highest in the periodic table. And carbon, it's fairly high too, and we all know why lithium is important, because lithium-ion batteries. Carbon, because carbon capacitors are very special, because they actually discharge very slow, and they can charge very fast. They can charge on like a nanoscale. I mean, carbon can be worked with on quantum scales too, you know. Fluorine, where it's so electronegative, it could pass electrons fairly, actually very efficiently. And gold, it's catalytic actually, so it can actually help against radiation. It can help block radiation, and it has a high electronegativity. And radium. Now I believe it's radium used because of the radio energy, the alpha particles that are used. And in the past, people would find radium, and because it has a glow, they would think it has these mystical powers. Now, we thought it had these mystical powers, but found out that it kills us. Okay, so if you're not careful, you know, then you can kill yourself. I just find it ironic. You got alpha particles coming from here, alpha. Then you have electrons, which is current, omega, Ohm's law, which gives you current through electrons, and that's omega. So alpha and omega, it just really, really ironically, coincidentally, it's weird. It's just weird. Oh yeah, the electronegativity of gold and carbon is actually precision resistance. So they can pass electrons very easily, and if they were actually in unison with each other or whatever, if they were combined in, if they needed to be in an electro generator in some way, they would actually work very effectively. And by doing like a galvanized cell, galvanic cell or voltaic cell, whatever, if aluminum and copper, the potential difference basically between the both is a half a volt, and if you do the difference of potential between these two, you'll get 5.1. It's just kind of ironic that kinetic energy, it's 5 alpha particle. The kinetic energy is 5 mega electron volts, 5% the speed of light, 5 million volts shared in or stored in a nucleus, helium-4, basically. So it's all weird that all these coincide with 5, and everything always lines up, even the molecular structures and being bipyramidal, just like the pyramids, because this is basically, I believe, how the pyramids work. This right here is actually this is always depicted, this generator is always depicted in hieroglyphs, I believe, alright? And this is supposed to be the avenue of the Sphinx here, okay? These right here is what they say they moved heavy stones with, you know? And if this is under the Sphinx and the Sphinx is here, then I believe the Sphinx is actually a heat sink for it. And you have a smaller generator in here that starts it, and it's actually the opposite, you know? You got your cold and your hot, and then this is your cold, or you're hot and then you're cold, you know. So it's basically like it reverses, but it's a good and efficient way, and probably how the primitives would have effectively stored energy, you know, or found out how energy works, you know. They would have used the best way that they found that would work, most effective for them. And here, like, here's a crystal radio. Basically, it has all the same elements as the pyramids of Giza. Like, you have the surface area, which is your antenna. You have the girdle stones, which has 3 in the pyramids, but you only need 1 diode. Okay, you have your king's chamber, which has this capacitor in it, this thermoelectric or radioisotope thermoelectric capacitor in it. You have your queen's chamber, which is the output or whatever discharges the energy, and I think it goes to the capstone and then is discharged to the atmosphere. Here's the antechamber, which is the ground, you know, the grand gallery, which is the coil, you know. I mean, it's like a giant radio, really. I mean, it's a giant transmitter and receiver. I just found, yeah, this was ironic too. The 369, they all have 2 shells, which is 6 altogether. Then you have your gold, which is exactly 6, and then in between all these, you have your 6, 12, 18, which is 6. You know, so it's always weird that it comes up 6. Now, the reason I believe the alpha particles are so important is because this the lead shielding of this Soviet reactor turned into gold, basically, and alpha particles are at play there. And this one guy, he got the Nobel Prize for doing it, or a Nobel laureate, whatever his name is. He was basically using bismuth, and bismuth puts off alpha decay. And the last time was in the late 80s, these guys was working on it, and they were actually using beryllium gas, and beryllium gas has alpha decay. And they were just putting a lot of amperage through it, okay? And that's basically this concept here, you know? I mean, I found this out after I'd figured this out, so that kind of blew my mind once I found that out, you know, because it's almost the exact same thing. You're running a nuclear energy here with the ionized particles, you know, and they were running electricity through this gas, which, you know, you have the ionized gas up here, you know. So, I mean, it's weird how everything kind of coincides. Now, the lead into gold. Now, I believe, okay, now we talk about in the past, they did electroplating. Oh, they electroplated their gold or whatever, yada, yada, yada. Now, what do you think that would mean? If they had a radionuclear arc, and they were doing that, using that electrical arc, that kind of spark, or basically to electroplate, I bet they were electroplating lead into gold. And all you have to really do is strip the electrons away from it. Now, you're going to get a nuclear gold, basically. It's going to have some kind of, it's going to be a gold isotope, because unless you can get the 118 neutrons, then you're not going to get exactly gold. You'll get a gold isotope. So it'll actually have some kind of radioactivity to it. And I basically believe it was alpha particles and heat and thermodynamics, basically, that turned the lead into gold. You know, I mean, you're affecting it on a nuclear scale with the radioactivity, and you're stripping the electrons with the heat, you know, so you can really turn lead into gold. And it's just ironic, too, that that's basically what coincides here with these events that took place when they coincidentally turned lead into gold.